Lateral. What do you know? What do you know about their angles? They all add up to 180, and they are all also equal. If your three sides are equal, then your angles are going to be equal, and there's only one option for that. It's got to be 60 degrees, 60 degrees, 60 degrees. So Christian, very first thing, fill in everything you know. Now, if you know this is 60 degrees, Christian, let's go from here. Do you see this D? It's on a straight line. How many degrees on a straight line? So if I'm using 60, how much is left over to use? Okay, write this in, Christian, 120. That guy right there is 120. Okay, now, Kenzie, focus in on this triangle right here. This guy right here, BCD. There's 180 degrees total, right? We're using 120, so what's left over to use? Okay, 60. Now, Kenzie, look, do you see this congruence mark in this one? That means these two are the same size, the same length. If they're the same length, the angles opposite are the same length. So this guy right here is the same as this. They're equal. And if there's only 60 degrees to use, how big is each angle? They've got to be the same. So they got to be 30. 30, 30. Okay, that's all we're going to do because we're running out of time. And then from there, you're going to have to tell me which ones isosceles. Do you see a right angle anywhere? What about number 4? Do you see a right angle? Look right here. 60 and 30. That's 90 degrees. There's your right angle. Do you see an obtuse? Acute? Okay, you're on your own for these. But, Christian, on the test, you've got to prove it. You have got to fill in the angles. Did that make sense? This was the hard part right here. Filling in the angles. As soon as you got that, the rest is not too bad. Okay. You guys go on 7 and 8. You have got postulate says if you got 3 sides that match up, then the triangles are congruent. All the angles are congruent. You've got a side angle side. You've got an angle side. What else do we have? Angle side angle. Most of them are going to come from these 4. So let's see what you got on 7. On 7, you've got an angle, a side, a side, a side, a side. So is that going to fit any of the bottom order? Is there a postulate that's angle, side, side? Hamakwe? Huh? No, there's not. That's not. If you've got an angle and a side, look, your angle has to be sandwiched between your 2 sides. Devin, does that make sense? Your angle has got to be sandwiched right between your 2 sides. This guy right here is not sandwiched between your 2 sides. Would it be side angle side? Okay, if it's going to be side angle side, here you go. Oh, is that not erasing? Side angle side. Let me change colors. Okay, you've got a side, right? So this side and this side. Then you got an angle, this angle and this angle. So if we're going to use side angle side, the angle's got to be sandwiched between the sides. So your side has got to be which side? It's got to be this side right here. Because the angle is sandwiched between. Does that make sense? Your angle has got to be between the 2 sides. And this one's not. This one, you got this. You got an angle, a side, and a side. So 7 is no. There's not enough information. You can't make any of these work. 8. 8 is a yes or a no. Look, fill it in. If that's 90, that's 90. So here's what we got. I got a side is congruent to a side. An angle is congruent to an angle. What else do we have that they didn't give us? You've got this side right here is congruent to itself. So here's what I've got. I've got a side, and an angle. Can we make this one work? So I got a side, and an angle. What order are they in? The order's this: side, side, angle, or angle, side, side. It's either one of these two. If you start here and go clockwise, or if you start here and go counterclockwise. So 8 is the exact same thing as 7. 8 is no. If I have a side, and an angle, but the angle is not sandwiched between them, that's not enough information. So 8's no. What about 9? Alright, Kenzie, here's the trick on 9 and 10. Do you see these triangles right here? That means they are parallel. That means they're parallel lines. If they're parallel lines, JC, do you remember parallel lines? And transversals and corresponding angles and alternate interior angles. Do you remember all those things? That's what we're going to have to use. So JC, this angle right here is going to be the same as this angle right here, because of their corresponding angles. Okay? So here's what you got. You have got a side, an angle, and a side. So what's 9? 9 is yes. Which one are you going to match it up with? Tony. If you see these triangles, they're parallel lines. You're going to have to, on the test, I'm going to look for this. If you're going to use side, angle, side, I'm going to look for your angle. So you can't just put yes, side, angle, side. You have got to show me which angle you're talking about. You've got to draw the congruence marks, because it's going to be empty. This congruence mark is not going to be here. You're going to have to write it in with the pencil. And the only way you know to write it in is by recognizing that these are parallel lines. That's a transversal, so these are corresponding angles. That means they're congruent. Look at number 10. Here's what we got on 10. 10 is the same thing. So Kenzie, when you see these arrows, that means these lines are parallel. So this guy and this guy, they're parallel. Look at this transversal right here. Alright, if I draw a little arc right there, Kenzie, this top left angle, which one does it match up with? The bottom left angle. Because these two are interior. They're interior angles. Because look, if these lines, and I would do this on the test, draw your lines, extend them out. Your lines go on forever. These two are alternate interior angles. So McQuaid, make sure you put a congruence mark there. That angle matches up with that angle. Okay, what if I do this? What if I look at this transversal right here? This guy. What matches up with this angle right here? Let's do two congruence marks. What matches up with this angle? Yeah, it's alternate interior. So this guy right here, the bottom right. So far here's what I've got. I've got an angle matches up with an angle matches up with an angle. What else do we have that they didn't give us? There's a vertical pair right here. So let's draw three congruence marks. 3 here and 3 here. So do I have any sides? No, you don't. So here's what you got, JC. You got an angle, an angle, an angle. So is that a yes or a no? Do you have an angle, angle, angle theorem? No. So your answer is no. You have to have at least one side somewhere. If you don't have any sides, then you're up a creek. Not enough information. Okay, let's go 11. Let's look at 11. Well, let's pause. Hold on. Look at this guy. Oh, I'm frozen. If you see that little box, what does that little box mean? Okay, it's a right angle. So how big is a right angle? So if you're using 90, how much is left over? There's only 90 left over. That doesn't mean they're each 45. Or else, Christian, it would have this. It would have this mark. It would have congruence marks. Okay, now Christian, you got this much right here. You got 3x and you got 5x minus 14. So you have to write this. 90 is equal to 3x plus 5x minus 14. If I add this top angle to the bottom angle, it's going to equal 90. Tony, write it down. 3x plus 5x minus 14 equals 90. Now it's just algebra. The geometry's over. So you combine your like terms. What's 3x and 5x? So 90 equals 8x minus 14. Okay, now Christian, walk us through this. This is 8 times x minus 14. You need to get x alone. Do you undo the times 8 or do you undo the minus 14? No, you undo the plus and minus first. Undo the minus 14. So plus 14 on the right, plus 14 on the left. What's 90 plus 14? So on the left you got 104 equals 8x, and that's 0. Okay, 8 times x. How do you undo times 8? So divide 8. Divide 8. What's 104 divide 8? 13. X equals 13. Now on the test, you're done. That's all they want you to do, Kenzie. They just want you to find x. So if x is 13, let's go one more step. This angle right here is 3 times x. So how big is this angle right here? What's 3 times 13? So this guy right here is 39 degrees. How big is this guy then? If there's 90 and 39, what's left over to use? If they have to add up to be 180. 51. It's got to be 51 degrees. Alright, Amber. Look on 14. What do these 3 marks tell you right off the bat? So what do they got to be? There's only one option for them. How big are they? How many degrees in a triangle, Amber? 180. If these are all the same size, how big are they? They have to be 180 divided by 3. They have to be 60. 60. 60. Christian, you got to pay attention. Good. 60, 60, 60. Now, Tony, tell me you know this. Do you see these 2 angles right here? They are a linear pair. They're on a straight line. How many degrees on a straight line? If I've used 60, how big is this? This right here is 120. So let's set 5x plus 15 equal to 120. Write it down. 5x plus 15 equals 120. Aspen, that won't make sense? You know why to set it equal to 120? Now it's just algebra. So Aspen, let's go. You got 5 times x plus 15 equals 120. Do you undo the times 5 or do you undo the plus 15? So let's minus 15 on the left. Minus 15 on the right. What's 120 minus 15? So on the right you got 105. On the left you got 5 times x. 5 times what is 105? Divide by 5, divide by 5. X is what? 21. And on the test you're done. That's all I want.